Yeah. Okay, yeah. So, what are plan support tools? In the context of integrated planning are the information technology-based instruments, other as computational tools, methods, techniques that assist planners incorporating different components to support the planning process. They can facilitate the dialogue among all stakeholders by providing a way to read, understand, and discuss the city and enable citizens to actively participate in decision-making processes by providing them a way to really read the city in a more understandable way. They utilize data and also sparse into statistical analysis, but also we have to have in mind that as plan support tools, there are also the quantitative research methods that Dimitris also mentioned, either focus group interviews, but also participatory quantitative tools. And all of them, they can support this planning process, either as the visualization tools and media, but also as a way to deduct some results, some conclusions. So the multifaceted nature of plan support tools cannot be exhausted in one lecture, and specifically in a 20-minute one like this one. I will try to focus on some fundamental aspects of the built environment, which are components of the grid planning in our point of view, but also are elements of the city that it's more easy to find some quantitative information, data. So it's easier to really implement these types of analysis. I will share in the background the selection of some fundamental metrics, methods, computational tools, and other sources needed for such analytical tools. I will focus on the build form and build density, urban mobility and network configuration, and also activity users and functional mix. So let's discuss a bit about the different analytical tools and metrics. So about build form. As you may understand, is a crucial aspect of describing a plan in a city and a fundamental element of urban form. However, build form and build density should not be approached as a single variable phenomenon, because as you can see by this illustrative example, the same density can mean very different things in terms of form and in terms of the image of the city. So we need multiple metrics to meaningfully capture these different typologies, and more importantly, understand the difference of spatial meaning that they encompass. So from now on, I will describe some metrics about build form and density, and accompany it with some maps that are being used actually either in planning applications or in a more research examples, but all of them are useful for planning the city, at least in my opinion. For example, here we can see the construction period of Athens as in a block level, but also the different construction materials, which are very illustrative in terms of the different social classes that inhabit the city. A different aspect of the city can be seen by the more frequent, the more usual metrics of build form, with the building height, the number of levels, but also the ground space index, which refers to the percentage of built-up area in each block, and also the floor space index, which is the whole volume of the built volume per urban block. And also the open space ratio, which reflects the pressure of the non-built environment put on the built environment. Sorry, the built environment put on the unbuilt environment. So here we can see the floor space index for Athens again, and here the open space ratio for Athens. We can see how different complementary images we can see with these two maps. Now, let's move on a bit with some metrics about mobility and configuration. As you have probably we have heard in other lectures from Ilaria, but also from Ed from Space Index. Space Index is an important method for analyzing and understanding the city. And since city can be approached as a structured factor spatial system that is self-organized through the interaction of network and human activity. And the street network is the urban element connecting all urban configurations, and as such has an architecture that is set in geometry, topology, and scale. Therefore, Space Index tries to quantify and conceptualize this property of the space to shape human movement and ultimately activity in the city. Apart from the analysis of the configuration, in the context of integrated planning, conventional sustainability metrics are also important. And more specifically, the analysis of pedestrian accessibility and active mobility characteristics, as well as the analysis of public transportation network, are crucial for supporting people-centric plan of the city. I wanted to highlight this because we tend, myself included, to be more excited probably in more complex and intriguing metrics that, for example, Space Index offers, and sometimes tend to forget or not put the focus that needed on more conventional and simple metrics that really describe how the public transport is, how is the infrastructure for pedestrian accessibility and stuff like that. So, for example, here we can see how the walkshed area that is provided by the centers of identified centers of a city, and how the established centers only facilitate half of the city. Also, the dance of public transportation stations is very important, and also the frequency of public transport service. Okay, I put this slide twice, but this is what I'm going to show, which is what is the walkshed area of metro stations in Athens, for example. We have the 400 meters isochron, the 800 meters, and 1,200 meters, and you can see how the existing network covers a part of the city, but not the whole, and how, for example, the center areas of the city are more or less very well connected, including some areas that they're planning to do new stations without really understanding the point of it. But on the other hand, we have other areas such as, I don't know how familiarized we are with Athens, but for example, Kypseli, or I think here is Sepolia, or here is Pagratic. It's very under service, and really need some the metro stations would be really useful in these areas. But also, we shouldn't forget the basic infrastructure that is important to understand how mobility can be facilitated. For example, if we start with the level of service based on pedestrian accessibility infrastructure, you can see a very different image in the city. For example, here is in Koukaki. If we just see what is the adequate level of service for only able-bodied users with a minimum sidewalk of more than 1.5 meters, most of the city of this neighborhood is service more or less. If we see what is the adequate level of service for all city users, meaning that it has an existence of tactile pavement, but also curb ramps per sidewalk section, we can see that this percentage with the blue, let's say the adequate level of service streets are very few. And if we really search for the comfortable level of service for all users, to really have a sidewalk width for more than 2.5 meters, 2.1 meters, to have the existence of tactile paving and presence to curb ramps, are only this very limited part of the network. I will talk a bit about Space Index, but not too much. You have seen about it. I think it's a very interesting analysis to incorporate, not really because it is the most important thing in the world, but because it reveals a layer of information, a lot of the times not included in conventional analysis in urban planning. The inherent property of the network to invite and save movement. This is, in my view, an important aspect that we need to focus. Not really does doing space index analysis in a way that this solves all our problems, but to use it as a layer of information to be incorporated with land uses, with public spaces, with emotional mapping, participatory mapping, a lot of things relevant to what we're doing every time. But it offers this kind of information that most of the times is not there if we just see the conventional analysis of urban space. Now about functional mixture and use and activities. I will try to be a bit more brief about it. You know the importance of land uses and functional activities and stuff like that. If you live in a city, I think that it's one of the most easy understandable features of it. If you have a commercial area, a lot of people will be there. If you have a residential area, not so many people will be there, to say the obvious. Oh, sorry. So that's a bit, that's some metrics to understand this kind of different representation of the urban space. The population density and the functional density, which is the first two maps, shows this complementary image of the city, but also we will see the functional diversity that each block has. We can combine maybe all of them and understand the functional type and the functional form, let's say, of the city. And the final slide about metrics and about functional mixture. For example, here on the left, we can see the prevailing land use type of the blocks in Athens, and how this can really describe and make us understand what is the functional character of the city. And on the other hand, we can use more advanced metrics to identify urban centers, even in the whole metropolitan Athens. Now, I will try to be a little more brief about this kind of stuff because it's mostly there for you to search about it and use them if you wish. In terms of methods, there's some basic methods in GIS and stuff like that about overlay, extraction, and proximity analysis. If you are even a bit involved with GIS, you know about them. Either it's buffer, intersect, stuff like that. Then if we try to go a bit in more advanced things, to map patterns and clusters, you can use kernel density estimation, spatial correlation, stuff like that. I know that you may don't know all of them, but I'm putting them there just for you to search about it if you wish. And also network analysis, which apart from space net, which in its core is space index analysis, it also refers to other metrics, either if you're talking about voxel area or destination cost matrix and stuff like that. And I put two slides about computational tools, just to have them in mind and search about them if you wish to be involved in more advanced spatial analysis. Here are some more space index focused ones. And here are some about urban morphology and also urban centrality in terms of urban center identification. And here is an open source plugin about walkable access and permeability. Finally, we should think about the resources, and especially we talk about macro analysis and analysis in the level of the city. Urban Atlas is maybe one of the more valuable resources to know about and search if you trying to work on a city level. It has very interesting information that it's open and useful for all urban Europe. And also OpenStreetMap, which you know probably how important data it has. Of course, it differs from city to city. For example, Athens is different from Thessaloniki or from Nicosia. But you should have in mind that as the time goes by, its reliability goes higher. And also, always look for the city-specific data. Look for the GIS portal of the municipality, the statistical authority of the country, and probably you will find some very valuable data to work with.